Today we're gonna evaluate this double sum with an integral. First we have to see what this integral is. If we look at here, we have a constant b factorial. So we can move it out. So the integral becomes 1 over b factorial times the integral from 0 to infinity of x to the b over e to the ax dx. This can be rewritten as 1 over b factorial times integral from 0 to infinity of x to the b times e to the negative ax dx. Now, this integral is very familiar. It's the Laplace transform of x to the b. So, first let's see at the Laplace transform of x. We know this is 1 over a squared for a bigger than 0. So just keep this in mind. Now, we're going to use integration by parts to evaluate this integral. So the formula for integration by parts is the following. So, now let's rewrite this integral here to solve it. We're gonna set e to the negative ax to be v prime, thus v is negative e to the negative ax over a, and we're gonna set x to the b to be u. Thus, u prime is b times x to the b minus 1. So, let's plug in the numbers here. Negative x to the b times e to the negative ax over a is this term. And we evaluate from 0 to infinity. And this is plus this term, which is the integral from 0 to infinity of x to the b minus 1 times e to the negative ax over a dx. Now, let's do this. So, the Laplace transform of x to the b will then be this, and if you plug in infinity here, you might think this increases a lot, but this increases faster. This power increases faster than this because the power is multiplied by a and a is bigger than 0. So this term becomes 0, so the whole thing is 0. Then minus this with infinity. If you plug in, not infinity, this with 0. If you put 0 here, it's just 0. so the whole thing is again 0. And then plus, we move out, and then plus, we move out the constant b over a, because there is also another constant here, times integral from 0 to infinity of x to the b minus 1 times x to the negative ax, but actually it's not x, I made a mistake, it's e dx. So what we get here, if you look closely, this is just the Laplace transform of x to the b minus 1. So we see that this is equal to the Laplace transform of x to the b, and this is also times b times a, b over a. So this is an important property we found out. So let's do Laplace transform of x squared to find a general formula for Laplace transform of x to the b, because this does not help, this just goes again. It doesn't give us a general answer. So this will just be that the Laplace transform of x to the 2 minus 1, so Laplace transform of x, which as we said here is this, times b over a, in this case b is 2. This becomes 2 over a cubed. Now, let's see at Laplace transform of x cubed. This will be 3 over a, because of this, times 1 over a squared times 2 over a. This becomes 3 factorial over a to the 4th. Now you can see a pattern here, and I'm gonna write it down. It's pretty easy to see that the Laplace transform of x to the b is b factorial over a to the b plus 1, or b factorial times a to the negative b minus 1. So we found out what our integral is. So what we get here, we found what this is. So because it multiplies with 1 over b factorial, the b factorial here cancels and we're just left with this. So now we move on and we go to here. So the sum a b equals 1 to infinity of a to the negative b minus 1. This is what we have to find now. So this can be rewritten as a geometric series. 1 over a times to the power of b plus 1. And we know for geometric series that they converge to the first term over 1 minus r, where r is the thing in the bracket. And yeah, r is 1 over a. And for this to work, r must be between minus 1 and 1, in which case it is, because a is always bigger than 1, and since we're dividing 1 with a, it's always smaller than 1. So, let's do this. The first term will be 1 over 8 to the power of 1 plus 1, or 1 over a squared. And then we have to divide by 1 minus r. So 1 minus 1 over a. This becomes 1 over a squared divided by a minus 1 over a, which is a over a squared times a minus 1, which is 1 over a times a minus 1. So this is it. Now we go to the next sum. Here. So, sum from 2 to infinity of 1 over a times a minus 1. This we'll have to find out now. Let's break this fraction into 2. 1 over a times a minus 1 should equal two different fractions. Let's say sum a over a plus some other b over a minus 1. Now let's find out what a and b are. 1 equals a times a minus 1 plus ba, and this equals a plus b times a minus 1, meaning that a should be negative 1 and b should be 1. Now, let's do it using this split fraction. So, it becomes sum from a equals 2 to infinity of 1 over a minus 1 minus 1 over a, or the limit as n approaches infinity of the sum of a equals 2 to infinity, or not infinity, it's n, because it's a limit, of 1 over a minus 1 minus 1 over a. This is the limit as n approaches 0, no, as n approaches infinity, of 1 over 1 minus 1 over 2 plus 1 over 2 plus and so on. And in general terms, it's just this until this. This continues until infinity. And you can see this is the limit as n approaches infinity of 1 minus 1 over n. Since n approaches infinity, this term becomes 0, and 1 minus 0 is 1. This is the answer.